Okay, today our focus is going to be on inverse trigonometric functions and mainly how to integrate those. Okay, yesterday we went over differentiating inverse trig functions. So now we'll go ahead and work with the inverse of differentiation, which is integration. Okay, so let me go ahead and start off with giving you our basic integration formulas there. So the integral of u prime all over the square root of a squared minus u squared dx is arcsine of u over a plus c. The integral of u prime over a squared plus u squared dx is 1 over a arctan of u over a plus c. The integral of u prime all over u square root of u squared minus a squared dx is 1 over a arcsecant of the absolute value of u over a plus c. And just keeping in mind that arcsecant, who's paired up with cosine, its domain is from 0 to infinity, so it has to be positive there. Okay, so let's take a look at a couple of examples. So what if we started off with the integral of dx over the square root of 4 minus x squared? Okay, well, if you take a look at the three that we have up above, looks like this one might looks like it might be paired up with arcsine, if we could somehow write it write it to match up with that. If you take a look at arcsine and arcsecant, notice that with the arcsine you have your constant squared minus your variable squared, whereas arcsecant you have your variable squared minus your constant squared. As far as the arctan, it doesn't really matter if I put the constant or the variable first, because there's no square root there. So this one definitely looks like it matches up with arcsine. So if we were to rewrite this, we can write it as the integral of dx over the square root of 2 squared minus x squared. Okay, so here it looks like our a is 2 and our u is x. So our answer is going to be arcsine of x over 2 plus c. Okay. All right, let's go ahead and take a look at our second example. How about the integral of dx over 2 plus 9x squared? Okay. On this one, no square root involved, so it looks like it might match up with the arctan. Okay, so how do we write that? Well, looks like we could write it as dx. Now for arctan, it's a squared and u squared, but I have a 2. So how could I rewrite the 2 so that it's a square, a property of a square? Well, we do that by rewriting it as the square root of 2 squared. And our 9x squared, we can write that as 3x quantity squared. Okay. So in this case, our a is square root of 2, and our u is equal to 3x. Okay. So our du is equal to 3 dx or 1/3 du is equal to dx. So we're going to replace this dx with 1/3 du. So when we rewrite this, well, I know the integral of u prime over a squared plus u squared dx is 1 over a arctan of u over a plus c. Okay. But before I do that, I need to go ahead and write it in terms of u. So I can bring the 1/3 outside. So that's 1/3 times the integral. And I'm going to replace the dx with the du, or the u prime. Okay, and here now I have my a squared plus my u squared. So that's the square root of 2 squared plus 3x squared. So our answer again is 1 over a. So it's going to be 1/3 times 1 over a, 1 over square root of 2, times the arctan of u over a. So here u over a would be 3x over the square root of 2, and then plus c. Okay, and I can leave it like this, or I can call this 1 over 3 square root of 2. At this point, don't really focus too much or bother about changing this to or rationalizing the denominator. On the AP Calc exam, they're not testing you on the algebra, they're testing you on the fact that you know the calculus concepts. So you could very well leave your answer with the square roots and the denominator there. That's not an issue. Okay. All right, let's go ahead and take a look at our next example. Okay, so our next example, we have the integral of dx over x times the square root 4x squared minus 9. Okay, and if we take a look at our 3 again, this definitely looks like it's a secant. Okay, so this is the same thing as the integral of dx over x times the square root of 2x quantity squared minus 3 squared. Okay, so reverting back or looking back at our arcsecant, we know that the integral arcsecant, the integral of u prime over u times square root of u squared minus a squared dx is 1 over a arcsecant absolute value of u over a plus c. So in this case, our u happens to be 2x. Our du is equal to 2 dx, which means that 1/2 du is equal to dx. And our a is equal to 3. So we can replace this dx with 1/2 du. So I can bring the 1/2 on the outside. So that's 1/2 times the integral of du all over. Now our u is equal to 2x. Okay? So, our u is 2x, and I have this x here on the outside. Alright, so let's see, how are we going to do that? Well, we have the square root. Okay, so on the inside, we're going to have the square root of u squared minus a squared. 2x squared minus 3 squared. Okay, u is equal to 2x. So x is equal to u over 2. So this x here, I can replace it with a u over 2. I don't know if I want to do that. No, you know, actually, I'm going to just go ahead and leave that x there. Okay, because I have this in terms of x. All right, so my answer then is 1 over a, 1 over, well, I have this 1/2 outside, 1/2 times 1 over a, so times 1 over 3, arcsecant, absolute value of u, so absolute value of 2x divided by 3, and then plus c. Okay, I hope that was right. Let's go ahead and take a look at our next example. The examples that you have with the e's, those are always a little tricky. So let's take a look at that one. Okay, the integral of dx divided by the square root of e to the 2x minus 1. Okay. Just keep in mind that e to the x quantity squared, when you have a power raised to a power, same thing as multiplying the exponent, so that is our e to the 2x. Okay. So this one looks like it's in the form, we have a u squared minus a squared. U squared minus a squared. So it's not arcsine, because arcsine you have the square root of a squared minus u squared, but here I have my variable first. So if it is going to work with anything, it is going to work with arcsecant. So I put a question mark there. So let's see. All right, if we let our u equal e to the x, then our du is equal e to the x dx. Okay? All right, so that means that du over e to the x is equal to dx. And our a is equal to 1. Okay, so we have, let's see if we start replacing stuff. So we're going to replace the dx with du over e to the x. So then this becomes the integral of du over e to the x. And then here we have the square root of e to the x squared minus 1 squared. So it looks like now it is in the form of arcsecant, where our a is 1 and our u is e to the x. So our answer would be 1 over a, which is 1 over 1, times arcsecant of u over a, absolute value of u over a, so that's e to the x. And e to the x is always positive, so I don't really need the absolute value. So it's arcsecant of e to the x and then plus c. So that's our answer there. Okay, that was a very interesting problem. All right, let's go ahead and take a look at another example. All right. So this one, how about, okay, how about the integral of x plus 2 divided by square root of 4 minus x squared dx. Okay. Now we've seen in various problems before that when you have a problem like this, we could sometimes split it up, because we know that if we have a plus b over c, that's the same thing as a over c plus b over c. Those are equivalent. So just by looking at this, I know the numerator is not a derivative of the denominator, or even the radicand in the denominator. But if I split this up, so that's x over square root of 4 minus x squared dx plus the integral of 2 over the square root of 4 minus x squared dx. Okay. Now this problem here we were able to do in chapter 4. There's really nothing special about that. We're going to let u equal 4 minus x squared, du is negative 2x dx, and we can work with that. The integral of u to the negative 1/2, etc. Whereas this one looks very familiar. It looks like it could be arcsine, because I have the square root of a squared minus u squared, where my u is x. So this one is just plain, and this one looks like it can be arcsine. So let's go ahead and finish this up. All right, so on my first one, we're going to go ahead and let u equal 4 minus x squared. Du is negative 2x dx. So negative 1/2 du is x dx. So we're going to replace the x dx with the negative 1/2 du. So my first integral becomes negative 1/2 times the integral of du, or actually, let's just go ahead and call this u to the negative 1/2 du. Okay, that's my first one. Okay, my second integral, we can actually bring the 2 out front. So here, 2 times the integral of 1 over the square root of 2 squared minus x squared dx. So on this one, we're going to set a is equal to, u is equal x. I think so. And du is equal to, du is just equal to dx. Okay. You're going to be in my video.